Thank you very much for joining. My name is Dr. Lucia Sironic. I'm a medical doctor and researcher at GlycanAge, and this is another one of our educational webinars. And today we'll be talking about peptides, unlocking peptides for longevity potential, and we'll tell you about some of the applications of peptides in longevity medicine and healthy aging. So today with me, I also have Dr. Julia Juric, our PhD scientist at GlycanAge, as well as Dr. Luis Martinez. Dr. Luis Martinez will tell us a bit more about peptide categories and different domains that peptides are being used in. And then Dr. Juric will tell us about some of the research that we have been doing at the GlycanAge on this topic. So we'll have a Q&A session at the end. So feel free to post any questions there instead of in the chat option. So I'll tell you a bit about why we chose to do this topic, what peptides are, why they are so pharmacologically attractive, and then I'll leave Dr. Luis Martinez to talk to you about some case studies and examples. So we decided to pursue this topic because obviously in the US, at least, peptides and peptide therapeutics have been quite popular for some time now. So even if you read anything as Goop or GQ, you'll see that peptide therapeutics have been getting a lot of attention and have been mentioned in the context of wellness and recovery as well as longevity. And at GlycanAge, we normally deal with quite a few inquiries about peptides and how their use might change somebody's biological age. I would also say that having recently attended the A4M conference in Las Vegas end of last year, that's also a topic that's been explored there in the context of mapping the longevity blueprint. So I think this is just one attempt from GlycanAge to sort of bring this topic to our attention and to see how actually we can use peptides in the context of longevity medicine. So just some basic science very briefly at the start. So what are these peptides? So it's good to sort of zoom out a bit and then zoom in on the basic building blocks of peptides, which would be amino acids, which when combined to form chains, these different amino acids combined and sort of brought together by peptide bonds basically make peptides. The definition of how many amino acids you should normally look for in the peptide, well, that ranges in between 2 all the way to 50. But we most often talk about peptides and their molecular weights being between 500 and 5,000 daltons. Putting that aside, obviously, when you have larger peptides with sort of longer chains, that would be your polypeptide. And when you combine 2 or more polypeptides, you basically get your protein. More importantly, I think functionally, peptides are hormones and neurotransmitters, growth factors, and ion channels. And I like to call them multitaskers because they do seem to have many different functions. No matter which tissue or cell look at. So we usually talk about peptides having this pleiotropic effect. So just some interaction I thought I would include here. I would like to ask you, all of you in the audience, if you could tell me which of these are naturally occurring peptides, meaning that the ones that our body makes for us. So I'll go through the list, and if I just could get some either in the chat, or I don't know if you can give me, can reply with any emojis, but what do you think about insulin? Is that a peptide or not a peptide? So insulin would be a peptide. Okay. What about oxytocin? Let's see what you say. Okay, so oxytocin is another peptide. What about our GLP-1 analogs or agonists? I think this is a fairly easy one considering all the media attention they get. So yes, that would be another one of your peptides. What about vasopressin? Just yes, no in the chat is enough. Yeah, I think I'm making it a bit too easy now, am I? So vasopressin is again another peptide. Okay, so the next three, let's see what you think about the next three. So ACTH, sorry, I kind of clicked on too fast. So that's another peptide. Leptin, would that be a peptide? Leptin is another peptide. And then BNP, I think the acronym says that we can see letter P there. So yes, that's another peptide of yours. So basically, this is just to show you how many of them there are really. I mean, I just kind of pulled some of those more famous ones, but basically peptides are everywhere, and they do really many different things for us. So just briefly on the sort of therapeutics development side of things. So the first peptide that was ever used as a therapeutic that you may know of was insulin, and that was just over 100 years ago. And in the first few years, it basically went on from just about being used to being massively produced, which meant that insulin that came from animals and was animal derived wasn't enough. So we started using recombinant insulin. And then as time went by, when I mean we, I mean pharma industry and biotech realized that yes, we can use the peptides that we naturally make, but we can make them slightly different in our favor, meaning that we can make them more stable or more longer lasting. So this is what the second sort of category would be, so the peptide mimicking drugs. And here are all of your GLP-1 agonists, Ozempic, Trulicity, and Rybelsus. And I think this is probably the most important modification that we realized that help us use peptides in a larger variety of different cases and scenarios. And lastly, there are also some peptides of natural origin, other natural origin. So, for example, snake venom has been used as a VEGF analog. So, definitely widely used. So what makes them so pharmacologically attractive? Before I tell you that, I'd just like to draw your attention to this figure, which shows you on y-axis, obviously sales in billions of dollars in 2019, and these are all the top-selling non-insulin peptides. And obviously, if you look at this, you will see the first three are your GLP-1 agonists, and the sales profit is just mind-blowing here. And for anybody actually interested in just understanding a bit more about peptide therapeutics development, I can highly recommend the paper that was cited here. And if I'm not wrong, we'll be distributing the slides afterwards. So you can just click on the link. It provides a really nice overview. But yes, you see that obviously apart from GLP-1 agonists, there are other peptides here. Some are your growth hormone secretagogues. So definitely a wide variety, but in terms of profit, I think there is no stopping them right now. And actually, if you look back in the last, so from the beginning of this century until now, you'll see that the FDA in the States approved more than 30 peptides as drugs, and actually a vast majority of those were approved in the period from 2016 to 2022. So I think we'll just be seeing more and more of these being used. why peptides and why not small molecules such as aspirin or biologics? The size matters here. So obviously, if you compared small molecules such as aspirin to a peptide to a biologic, I think that's the best analogy would be if you compared a bike, a small molecule to a car, a peptide, and a plane. That would be your biologic therapeutic. Peptides are, because of that size and some of the other traits they have. So if you compare them to small molecules, they would be more specific, would have a good safety profile and good efficacy. However, in comparison to small molecules, they are less stable and have lower membrane permeability and shorter half-life. So obviously all of these sets of benefits come with some drawbacks as well. In comparison to biologics, they are not as expensive. They do have better membrane permeability, which means they're able to get into a cellular compartment they need to get into and have low immunogenicity. But again, in comparison to biologics, they would be less stable and have a shorter half-life. So that would be just the summary of why you would want to choose a peptide over either of these two other drug types. And lastly, just thinking about the use and sourcing of the peptide, which kind of goes back to all the media hype some of the peptides have been receiving. So obviously we can be talking about, which we will not be talking about today, but we could be talking about prescription peptides for certain diseases and conditions that have been pre-approved by the FDA. And obviously this is all in the context of big pharma production of these peptides. But I think what we're here today to talk about is really the off-label use of peptides. So meaning that you're prescribing peptides, obviously off-label to a patient or a client that you deem would get some benefit from it. But I think the third point, black marks of peptides that are being sold and sort of consumed as part of the black market is something that we have to be quite aware of. When I was doing some research on this topic, I came across this term, Ozempic parties, obviously referring to the massive overuse of Ozempic, as you can see in the events where people get together to take that drug, which makes them look thinner, despite the fact that there are obviously lots of side effects. So I think bearing in mind some of the good stuff that I believe Dr. Martinez will tell us about, I think it's also good to be thinking about how all of this, all of these different peptide medications can get to the black market and be used highly likely for all the wrong reasons. So this is it for me. I will just stop sharing my screen and I will allow Dr. Martinez to tell us about some practical examples.
Sure. Hello there. Can you hear me?
Yes, we can hear you well.
Wonderful. Hello, everyone. Thank you for having me here. I will share my screen now. See, I assume you can see this. So I will talk a bit on more the clinical side of the peptide applications. Just a little background. I'm based out of the United States. I have offices in Florida and Puerto Rico, and I'm also very involved with physician training education on the clinical use of peptides. Here in the States, we've been using peptides for quite a few years. And, for longevity purposes, age management, anti-aging purposes, I wanted to highlight just a few of the peptide categories that are more commonly used for these purposes. And most of our peptides, we are able to source from compounding pharmacies. And it's been a bit of a challenge with the regulatory landscape changing, constantly evolving. FDA has revised their definition of how many amino acids constitutes a peptide, so that's been challenging. But anyhow, so a few of the popular peptides. So we have in the growth hormone secretagogue category, We have a few of them like sermorelin, ipamorelin, CJC1295, tesamorelin. So these peptides are mainly used to increase the growth hormone secretion in patients. And we know that when we increase growth hormone production, we can achieve faster tissue repair, response, regeneration, improved body composition, increased muscle mass, increased fat mass, and skin repair. So it's usually these categories are very popular with patients. As they grow older, their IGF-1 levels go down. And by boosting endogenous growth hormone production, you can get some clinical benefits there. Now, this is not directly growth hormone. We're actually just stimulating, maximizing endogenous production. So in addition to the growth hormone secretagogues, we also use the thymosin, specifically thymosin alpha-1, thymosin beta-4, and thymin. The thymosins have different roles in our body. TA1 or thymosin alpha-1 is mainly for immune stimulation, immune repair. It can help fight off senescence, immunosenescence. It's been clinically studied for many, many years, many articles published on the use of TA1. Thymosin beta-4 is more of a repair peptide that can help repair tissues. Has been studied in the field of dermatology, ophthalmology, neurology. So we use it more for acute situations. And then the thymulin, which has been sort of an in-between benefit there. It's been shown to both have anti-inflammatory benefits and also repair capacity and immune modulating benefits. Following on the peptide categories that we usually use, when we look at longevity, we're talking about epithalon, pineolon. These are pineal-derived peptides, and we also have peptides more focused on repair and anti-inflammatory capacity, such as BPC-157 and KPB. There's also some mitochondrial peptides, mitochondrial targeted peptides, such as MOXC, SS31. Some of these peptides have already gone through clinical processes, such as SS31. So for some of these peptides, we have a lot of clinical data. There's also cosmetic peptides, such as GHK copper, which actually has a role beyond cosmetics. It's also a potent gene modulator, anti-inflammatory repair peptide too. Plus, there's many more. I mean, obviously, we don't have the time to highlight all the different peptides we're using clinically, but just wanted to give an overall overview of the different categories in which we're using peptides clinically with our patients. I know that in other parts of the world, it might be harder to get some of these peptides or easier. It really depends on where you're at. I do a lot of international lecturing and consulting, and some countries are a lot easier to get peptides, others are not, but we try to do that. So what are, peptide benefits? How can they help, right? One of the things that is very positive about these peptides is that the results usually are fast enough to get clinical response relatively quickly. And peptides can help with many things: energy, metabolism, memory, cognitive, faster repair, recovery, antimicrobial benefits, improved immunity, anti-cancer effects, and obviously enhanced longevity, right? So this is part of what we're looking at and why we're using these peptides. And it's really interesting because even before peptides took off clinically in the United States, a lot of them were already being used by bodybuilders and people in the healthcare and in the wellness sector, fitness sector. So they do have a long trajectory, these peptides. And, thankfully, we're just advancing the clinical aspects. How can these peptides impact biological life, right? Or what mechanisms could potentially be involved, right? So one of them is enhancing immune function, and the other is decreasing inflammation. And if you put those two together, you get the whole concept of targeting or addressing inflammation, right? We're also seeing increased repair process. and even telomerase activation. So some notable peptides with potential longevity applications. Again, this is just a very short list. I think there's many more peptides that can have these benefits, right? But I highlighted epithalin, GHK copper, thymosin alpha 1, and the growth hormone secretagogue class, right? Epithalin, it's a pineal-derived peptide, 4 amino acid chain. It was studied it was studied for many years, 9 decades in the old Soviet Union and Russia, and it's been shown to have an excellent safety profile. There's a, I know in Russia there were many studies on the peptide. So, and it's interesting because among the studies, it's been shown to increase telomerase activity, stimulate DNA repair, and have cells able to divide more than what would be their maximum limit. It's also shown benefits in chromatin expression, and clinically, it's increased longevity in patients use. Right? And again, very, very, very safe peptide. GHK peptide. So this is a tripeptide, glycyl histidoglycine. It's been extensively studied for cosmetic purposes. And it's usually associated with cosmetic benefits, a lot of creams with GHK copper, a lot of formulations, topical formulations. But really interestingly, the original research looked at repair, systemic repair, body repair, organ repair with GHK copper. I actually had the benefit of interacting with Dr. Pickard, who was the one who originally discovered this peptide and published a lot on it. And and again, he was very adamant that the repair aspect, the systemic repair, was more relevant or more important than the actual cosmetic benefits, which it does have. It's great for the skin. So if you want it, your skin, you can definitely use topical GHK copper. What's really interesting is it's been studied in the context of gene expression, and specifically even cancer expression. And it's been shown to modulate a lot of different genes and favoring more of an anti-inflammatory profile. And it's been shown to even silence some of the cancer-expressing RNAs. So we actually use it systemically in certain cancer patients and overall to stimulate repair processes. And then thymosin alpha 1, like I mentioned, extensively studied peptide, 28 amino acid sequence. It's an endogenous human peptide. It's responsible for a healthy immune system. And it's been shown to reconstitute the immune system in thymectomized animal models. So one of the things that I look at with thymosin alpha 1 is helping ward off inflammation, right? And this whole trend as we grow older towards senescence and the dysfunctional system. I've looked at using TA1. I've looked at CD4, CD8 ratios, and I've noticed improvements in the ratio, reverting inverted ratios with TA1. And of course, we use it for cancer, just general wellness, not longevity. And then, the growth hormone secretagogue, right? So I mentioned these. They will stimulate growth hormone secretion, and there's many benefits to having optimal growth hormone secretion in the aging body. And there's also some interesting studies where growth hormone has shown, for example, an impact on thymus gland rejuvenation, improving immune system. So there's a lot of things here that are coming into play when we're. Now I have a few examples very briefly that I want to discuss. Very interesting cases. This was first one was a 56-year-old female patient of mine. She has been on bioidentical hormone replacement therapy for the past 7 years. She's been using estradiol plus testosterone. And she's been doing 2 rounds of epithalin, right? 50 milligrams per cycle twice a year for the past 5 years. So she's been very active. That has been really her mainstream of treatment, the hormone replacement therapy and the epithalin, right? So she's 57. She She had a glycanage of 20. And all her blood chemistries are optimal, look wonderfully well. No systemic inflammation is almost zero. It's very, very controlled. She looks great, actually. She does TB, and she looks really good. And we correlated her telomere length to that of a average 27-year-old patient. So definitely there's been an impact there on what she's doing. And, we know also that estradiol therapy has a positive impact on biological age. It's been documented. So I think the combination of both doing the epibalin and having the hormone replacement therapy has been a great benefit. This second case, 62-year-old male patient, who's been also on hormone replacement therapy for the past 8 years. He did growth hormone therapy for 4 years. That was 7 years ago. After that, we just switched him over to the growth hormone secretagogue. So he was doing CJC with ipamorelin for the past 3 years. And, usually we will cycle these treatments. He was also doing the GHK coupling. Works out. Biological age of 47 for this patient. And again, same thing, mainstay of treatment is the hormone replacement and these peptides that he's doing. He's been doing really well. And what I like about the secretagogues versus actual growth hormone replacement is that with the secretagogue therapy, you don't have that risk of overdosing. It's all physiological, it's glandular production. So we're not, with growth hormone, if you go too aggressively on the dose, you can have some side effects and all that. So here we're just working with the patient and the capacity to produce. This other example with a 53-year-old male patient. So he was diagnosed at age 48 with a B-cell lymphoma. He's in full remission. He underwent both like a traditional chemotherapy, and also we also did the complementary therapies like peptide with thymosin alpha-1. He after the initial standard treatment, he has continued using thymosin alpha-1 on a weekly basis, right? And his biological age is 41. Full remission, the great CD4 CD8 ratio. And he's otherwise doing extremely well. Right? And it's interesting because usually with the cancer therapy, like the chemotherapies and such, you can observe worse outcomes. You can observe somatic cell damage. I've had some patients on who have done chemotherapy that different markers of biological age. They are older, right? So with this patient, he has continued doing the thymosin alpha-1. His chemistries are perfect, and he has a good biological age. And finally, this other example, a bit different, right? So this example was a 56-year-old male patient. He has a history of hypertension, hyperlipidemia. He's obese, obesity grade 1. He's been taking metformin for 500 milligrams at night for the past 3 years. He's not a diabetic. He's not diabetic. This was recommended both as a preventive measure by his primary care practitioner, as well as, because of the longevity potential benefits of metformin, right? Usually runs with an elevated CRP around 2 to 4. He's not a very compliant person. He has not really focused on losing weight. He has never been on peptide therapy or any other biological intervention. The only thing he was doing was the metformin, right? And we also know that metformin will work differently if you are going to be diabetic or not, right? So his biological age is 77. It's extremely advanced age. He has an appointment with me in a few weeks, and I hope he can take this more seriously, make some more significant lifestyle interventions, including some peptide therapy, to help improve his parameters. Right? So, you can see here different cases, different applications of peptides. Overall, I think we have a lot more to learn, right? But what are we seeing? Yeah. And this is a trend in my practice. I'm seeing that usually patients on the different peptide therapies are more consistently shown in lower biological age. And obviously, in addition to the biological age, you're getting a good quality of life and a lot of different markers that are improving. And, like I said, peptide therapies can act relatively fast. And so that's something that patients do like. They see that impact really fast. What is still, I think, missing or still pending, obviously, we still need more research into how particular peptide combinations can impact biology. And there's many other peptides, as I mentioned, the categories that I still want to look at and see how they can impact biological. For example, some of the mitochondria targeting peptides, the MAT2, and others repair peptides such as these. So I'm very interested in just going and looking more and more how these peptides can help impact and improve biological input in addition to other parameters. So more to come as we get more data on this, have more patients tested and followed through, and getting more practitioners in our network that are starting to implement the biological age test. So I think that we're going to be able to see a lot more on that end in the next few months, years. And, of course, if any of you want more information, you can also visit our site, Clinical Peptide Society. We're always very active with that sort of, learning and interacting with other clinicians, sharing data on this. So I will stop here, and I will let you continue.
Hello, and I'm here to present. So my name is Julia Juric, and I'm a senior researcher. Dr. Lucia gave a really nice introduction on the peptides, and Dr. Martinez gave us amazing case reports from his practice. And I would like to tell you more about the science behind our product, and this is the biological age test called the glycan age. Okay, so aging is essential part of the disease, and it happens on the molecular level. And this is basically where we want to catch it, measure it, and act upon it, because our test is made for preventative purposes. So what we are looking at is inflammation, and it is the chronic inflammation, so low-grade sterile inflammation that is happening in the body as people are getting older. And just recently, inflammation started and was put in side by side to the other hallmarks of aging. Chronic inflammation is a part of inflammaging theory, where it says that as people are getting older, the inflammation is piling up, and this is basically what is driving the aging processes. The term was coined by a scientist from Italy, Claudio Franceschi, in 2006. So the main question here is, can we actually measure chronic inflammation and act upon this information? So we've been researching glycans for the past 25 years now, and we can say that we found a way how to measure inflammation. And this is by looking at the specific molecules called glycans that are attached on the antibodies. So they're attached to the most prevalent antibody in the blood called immunoglobulin G. And this is important because antibody circulates in the blood throughout our bloodstream and catches all those small signs and small parts of the inflammation. So basically, glycosylation is a reflection of your body's health and chronic inflammation. It means that what we are looking at is the composition of glycans, and the glycans can be of different structure. The ones that have anti-inflammatory properties are the ones that are a bit longer and end with a sialic acid. and those short ones give antibodies pro-inflammatory actions. So basically, when we were looking at the glycan composition on antibodies of people from 20 to 80 years of age, and we did that on more than 100,000 people, we saw that there are specific glycan structures that predictably change with aging, and those can be used as aging biomarkers. Based on this, we developed an algorithm and set up a biological age test called the glycan age. So every person has a unique glycome because you have a unique ratio of the anti-inflammatory and pro-inflammatory glycans on your antibodies. And basically, it's a combination, the environment and your lifestyle and your genetics is shaping this uniqueness of your glycome. So in one independent research, glycan age was shown to be associated with multiple diseases, and we made it commercially available so that people and practitioners can track responses to lifestyle changes. And just last year, we published a review where we highlighted 72 different diseases and conditions and their specific glycosylation patterns. And obesity was one of those diseases. So we see now that people who are obese have increased chronic inflammation and their biological age is high. But if they change lifestyle and accept beneficial lifestyle interventions, so they decrease their BMI, they become younger. Also, you can become younger or decrease the BMI with the bariatric surgery. And in this example, in this study that we conducted, there was a single person decreasing their biological age for 37 glycan age years. So it's a massive decrease in chronic inflammation just by lowering their BMI. In our practice, so when our clients come to us and do their biological age, we see that if they don't do any intervention, so on average, they age year per year, unless there's an intervention that they're doing. For example, Professor Tim Spector, he is a healthy person. He didn't have any diagnosis, but there was diabetes history in his family going on, and he did metformin experiment. So he took a small dose of metformin for a couple of months, and his biological age went down. So he obviously was a bit inflamed, and then he managed this inflammation by metformin. So since metformin is mentioned as a longevity drug, we also did a study on healthy people. So can metformin be a longevity drug, a preventative drug for future diabetes complications or diseases in healthy people? So unfortunately, we saw that metformin in healthy people did not respond to metformin. Only one single person responded. So probably this person was similar to Professor Tim Spector, still not diagnosed, but with a risk to develop future diabetes. Our ongoing study is actually, we are looking at the effect of anti-diabetic treatments, so different ones, on glycans and chronic inflammation. So what we see with metformin, we see with other anti-diabetic drugs. So we see the similar, but what is most important one is that half of the people are benefiting from each of the treatment, and half of the people in the group, in the participant group is not. So here I'm talking about that personalization of the treatment is very important. And what we have is a test that can give you this answer. Is this treatment good for your client? So is it personalized? Is it optimal for your client? And what is most important for GLP-1 receptor agonists, so for Ozempic, we see that it it is really beneficial for G1. So this is the risk factor for all-cause mortality. So it's improving this glycan. What we would like to do is to do more research on this. So for now, we have this peptide research only in people who are diagnosed with a disease, so peptides that are used as medications. What we would like to do is do more research on peptides that are used mostly for longevity purposes. As a part of our report that you get with the glycan age, so firstly, we will give you a result of your biological age against your chronological age. So this would kind of mean that we are looking at the composition of your glycans against, and we are comparing it to a glycan composition of people from 20 to 80 years of age. And we are looking at if you're younger, healthier, or older, so aging faster than an average person of your age. After that, there is also an information of the amount of anti-inflammatory and pro-inflammatory glycans that you have within the indexes. And there is also information in supportive indexes that would give you the estimation of the cardiovascular health of your client and lifestyle. So it's the sleep, smoking, and stress information for your client. And we also provide the clinical actionability. So we give you advice on what things to check additionally and what interventions you can do to improve each of these aspects of health of your client. And more granular view on the health status is this last part, where we give you a cross-reference of a personal glycan profile of your client against the most research-supported diseases that we have in our portfolio. So we categorize this into metabolic and cardiovascular diseases, autoimmune and gastrointestinal, respiratory, and hormonal endocrine diseases. So you get a full aspect of your health, of the health of your client. So if you would like to test our product and see how the interventions that you are doing or you're doing on your client affect the immune system and biological age, you can use this special 25% discount with using the code Peptides25. Thank you.
Okay, so thank you, Yulia and Dr. Martinez. I think we had some questions in the chat. So there was one from Sabrina Patel, which I think probably Dr. Louise might be able to answer. So the question is, with the new limitations on peptides, such as the GHK-Cu and epithalon, etc., how are we able to get some of these medications?
Yeah, so I can answer that. Some of these, even with the limitations, there are still some compounding pharmacies that are offering the peptides in the States. I'm assuming the question is referring to getting them in the US, I would think. But so there are still some pharmacies there. If you want, any of you who would like to contact me for more information on that, how to get them, I can certainly give you some more information. Maybe email me. Can I just put my email here? Does that work? You can just email and I can refer to some.
Yeah, I think so.
Yeah.
So just put it in the chat.
Yeah,
I think that could work.
Yeah, there we go. I know that the UK and other places are a bit more challenging for these peptides. So, and that's unfortunate. I think in the States, we're actively, fighting these limitations because a lot of these peptides are able to be compounded. So it's just more of a regulatory issue, but yeah, we still have quite a few of them available. I see another question here on growth hormone proliferation.
Yes, please go for it.
Yeah.
Thank you.
Yeah, that's also very interesting. So, the data that we have on growth hormone use in patients, and even the peptide secretagogues, the growth hormone secretagogue use, does not favor an overall increased risk in cancer with their use. So overall, it's been shown to be quite a safe therapy. Again, I think the key here is if you're using growth hormone, you have to be careful not overusing it or overdosing it. I also, my clinical experience personally, I like to cycle if I'm doing secretagogue therapy. So, and I think that's the key there, where you do these, these treatments with the growth hormone secretagogues, and at some point you stop and you do some fasting and some senolytics to help clear out any unwanted cells. But again, overall, the data does not support an increased cancer risk with these therapies.
Okay, thank you. Dr. Martinez, so the question from our Zori, thank you for a great webinar. So which peptide would you start your 57, I think it was 57-year-old obese patient on?
Yeah.
So the one who
Actually,
hasn't started any peptides.
correct. So actually, that patient, we're going to do a few peptides. He's definitely biologically not doing well. So one, we will do some GLP-1s because he has to lose a significant amount of weight. So he's going to start on those. And two, I'm going to get him on some rounds of epitalon. I think that's a really good peptide when you're looking at longevity purposes. So we're going to do epitalon with him. And also because of the systemic inflammation, I plan on doing some GHK copper injections. And potentially down the road, some other, a lot of these patients, we will do multiple peptide therapies. But right off the bat, just the GLPs and the epitalon and GHK.
Cool. So there is a question from Ursula Tatch asking, do you have your clients sign more specific detailed consents when prescribing peptides? So this is a really good question.
We definitely do. If you let me see if you guys can see me here. There we go. We definitely do. If you visit our site, the Clinical Peptide Society, we have a lot of resources for practitioners, including a general consent form that we give patients on peptide therapies. I think it's very important for them to be informed and, the goals of the therapy, the potential side effects, risks, and how we monitor it. So definitely we do all that. One thing that's very popular in the US and I usually advise against is like buying online. Like there's a lot of these online peptide labs and people just go in and buy them. There's some issues with that because you can't really regulate that in terms of quality, product, and all that. So we only use pharmacies that, compounding pharmacies that are registered for these purposes. But that's part of the whole concept. I think there's another
Cool.
question.
Yeah, go for it.
Yeah, so there's one on the growth hormone combination with HRT. Yeah, I mean, if we're looking at the growth hormone secretagogues, one of the combinations we use a lot or have been using a lot was a CJC 1295 with the ipamorelin. And this particularly, it addresses two different receptors. It was producing really good results. We've also combined sermorelin with ipamorelin. And then there's also tesmorelin, which is controlled, right? So it really, I guess it really depends a bit on case by case specifics for patients. But overall, the CJC with ipamorelin is a good combination. Oh, there's another question here. Julia. There we go. Can sticking to bad lifestyle habits neutralize peptide benefits? Yeah, definitely. Lifestyle intervention will never be replaced. I know that we all try to, cheat on the lifestyle, and We want something that'll benefit us. So, but I mean, but having said that, I will tell you this, you know, if we look at it the other way around, some of these peptides can help neutralize some of these bad lifestyle habits, right? So it's you know, the anti-inflammatory effects, immune stimulating effects, all that. I'm actually in the process of writing a work on this, but I really feel that when we look at many of these peptides, right, what we're really doing is replacing what's being lost to the whole aging process. A lot of these peptides are endogenous, our body produces them. So as we grow older, very similar to the hormones. As we grow older, we stop producing adequate levels. So we're really replacing a lot of these in our body. But yeah, never forget lifestyle. But
Yeah,
save some
yeah.
room for the wine.
Yeah, so I was just asking in the context of a lot of our research is done with like on supplements, or is it nutritional supplements, or is it supplementing the hormones? But we see that the effect is not optimal if the person is not adjusting the lifestyle.
Correct.
So you don't have a full potential of the supplement that you're taking if you're sticking to the lifestyle, kind of you're neutralizing it. But also I'm interested in, so my specialty and focus is reproductive aging and fertility. So there's also one very interesting peptide. It's called kisspeptin.
Yes.
Yeah, and I think it's becoming very popular in the last years because it kind of rejuvenates the axis, the hormonal axis.
Correct.
And since a lot of people, like women, have a lot of trouble conceiving naturally, and it's been a lot of discussion about this, whether it's a bad lifestyle or is it hormonal disbalances or imbalances or something, but kisspeptin seems to be helping them with natural conceiving and restoring that axis.
That definitely, and you know, I've used kisspeptin. It definitely has that sort of benefit. One of the, I guess, depending on how you look at it, because when you're looking at hormonal reproductive health, it's definitely has a role there. When you're looking at, you know, kisspeptin as a way to stimulate endogenous hormone production, it's good, but if you're looking at the hormone levels that you want for certain, you know, longevity purposes, might be a little different, might be not potent enough. But overall, I think it's definitely a good option.
Thank
you. And how long do you, there's no question, how long do you suggest being on growth hormone injections and HRT? So, you know, again, I prefer the growth hormone secretagogues more than the actual growth hormone. So I would recommend if you're going to be on long-term therapy, you might look at secretagogues instead of the actual growth hormone. And hormone replacement therapy, I mean, as long as you monitor the patient adequately and you see the evolution, you can adjust dosing and all that, there really isn't an upper limit. I think we're learning that we can have patients long-term on these therapies and show benefits and do it safely. There's studies published on this. And, you know, we see more and more that these hormones, when used properly, and these peptides, can contribute long-term benefits. I can tell you that, you know, I have patients in their 80s on hormone replacement therapy, doing wonderfully well. Everything controlled healthy, they exercise, they don't look 80, 85 or so. So as long as you monitor adequately, you don't have a maximum limit there. And there's another one. What are the negative side effects of peptides? It really depends on the peptides. So that's the first thing. It really depends on peptides. Usually these peptides are very safe. For example, the most that we see are injection site reactions. Injecting, you get rash, burning, irritability. Some particular peptides can cause some flushing temporarily, but for most part, if dosed properly, they're very safe.
There is also one interesting question from Edward. What is the real reason that determines a responder or non-responder to peptides? So when is this point? So you put someone on the peptide, and when do you decide if this peptide is working properly? So is this Yeah.
That's a great question, and it really depends on the specific peptide and what we're looking at. For example, when we're looking at growth hormone secretagogues, right? So we want to measure things like IGF-1 changes in the blood. So ideally, if you're stimulating more growth hormone production, you should have a higher IGF-1 level. And of course, that should go hand in hand with the clinical benefits, right? The changes in body composition, repair, muscle mass, fat loss, etc. When you're looking at things like thymosin alpha-1, then you're looking at the immune system. So you're looking at, different markers, CD4, CD8 ratios. You're looking at, depending if you're using it for cancer response, if you're using it for other, autoimmune or other things, and you're looking at the different markers for the disease state. If you're looking at peptides such as, PHK, you might want to look at inflammation, systemic inflammation, GHK, KPD. And then some peptides are being used locally, like you can inject BPC into tissues, joints, tendons, ligaments to see if there's a repair response there. So again, it really will depend on the peptide and what it can be. I'll add with epithalin, for example, some of the more focused longevity peptides. Now we're going to be starting to look a lot more at the glycan age effect, right? Longevity impact and biological age as a primary endpoint for an understanding response.
We have another question in the Q&A section. It says, would adding metformin and medical peptides, so I guess combining metformin and peptides, be a good combination?
I mean, yeah, I think it could be. It's as you showed, if you're otherwise healthy, it doesn't seem that metformin is going to have much of an impact on your biological age, right? So, we have this other trial, the TAME trial, that's looking at markers of aging and metformin, right? So we might get some more information there. But can it be done? Yeah, definitely. You could definitely combine metformin with these peptides. That won't be an issue. Metformin has shown some other benefits, reduced cancer incidence, but again, it might be depending on the actual disease state that the patient is presenting. But it definitely can be done.
Okay, there are some questions. I mean, I'm not sure whether you would know this. I guess anybody else who is based in Europe, who knows how to access peptides in Europe. But I guess that's a bit of more of a geography question. I mean, I'm not aware of actually any of the clinics that deal with peptides regularly in Europe. So I think there's quite a bit of a difference between the States and the EU, and I'm pretty sure it's similar for the UK. So Sarah Law says, okay, so I think slowly peptides are coming into the European market, but it's kind of taken a long time. Another question from Alison says, do you ever envision peptides being sold in an over-the-counter capacity? But she's not talking about cosmetic peptides, but actually all of the peptides that you discussed.
I don't see that for the time being. I think most of these peptides, although they're safe, but they do require some sort of medical monitoring, right? So a lot of these peptides are injectable, or they require specific preparations. It's going to be, I mean, my opinion is it might be very challenging to actually make this over the counter, right? There are some peptide-derived supplements, some of the peptide fragments that are being sold in terms of like supplements, like capsules. You can get the PB4 fragments, BPC and such, which are sold for supplements, right? People take them as. But I think that when you're looking at specific intervention, it's more beneficial to do medical monitoring, especially with the
Okay, and then I think we'll finish with this question, but questions that keep coming in. So Sharon Christie says, how do you manage the patient compliance issue of daily injections when they might be using 3 at the
Sure.
same time?
You know, it's really interesting. That's a good question. A lot of the time we have when patients understand you, we explain to them the dosing schedule first off, right? And many of these patients are motivated. They're looking at wellness. They're looking at improving. They're looking at really taking charge of their health. So when you have this sort of patient, motivated patient, it usually is not a problem. They are willing to inject. These injections are sub-Q at night. So it's relatively simple. So, you know, if you have a patient that has issues with that, then, you know, they'll probably tell you beforehand, you look at options. There's some lingual options that we can work with and some other delivery mechanisms. But for the most part, my patients are fine with that at home.
Maybe we can also
Okay.
touch upon a little bit on the, it says negative side effects of peptides. I think that maybe this could be also connected with growth factor peptides and cancer cells, maybe in this context or maybe in general to say, I know you said that the peptides are fairly kind of safe, but maybe in this case, can you explain a little bit more
Sure.
if there is any specific situation where you should be taking some more action with the
I mean,
growth hormone?
for the growth hormone peptides, or secretagogues, what you really want to do is obviously you don't want to give this to someone with an active cancer. Right? If there's an active cancer, you're not going to give these particular peptides. You could do other peptides like the thymosin alpha 1, right? But so in that sense, you have to be careful. You have to make sure that the patient is healthy enough to do that. But you know, in patients that do not have an active cancer or that do not have any reason for high suspicion of cancer, they can use these peptides. And again, the data has shown that these peptides do not add an increased cancer risk. Right? And this is very similar. This is very similar to what we've seen with the hormones, right? With hormone replacement therapy. And many years ago, you know, we were told that testosterone would increase cancer incidence in men, testosterone replacement, or that estrogen replacement would increase cancer incidence in women. But now we know that's not the case. They do not actually increase cancer risk or increase cancer incidence. So what we know is that if the patient already has a cancer that maybe has not been diagnosed, then you might have an issue there because there was a cancer already, and cancer can grow, respond to many things. But we know that giving these peptides or hormones to patients who do not have cancer will not increase overall their risk for cancer development.
Okay, I think that's it, Julia. I think you're muted. I think we say we answered.
It's good. We've had some really interesting questions about a good feedback.
Yeah, really good questions. Yeah, and
Yeah.
I think I would summarize. Yes, lots of potential. Some geographical differences when it comes to getting into peptides, using them, prescribing them.
Sure.
But hopefully that will not be as prominent as before. And yeah, a lot of things to look forward to. I think both in terms of research and biological age. Oh, the last question. Okay, this is the very last question, and then we have to go. For short children. Oh yeah. So would you suggest growth hormone for a short child?
There's actually studies obviously on growth hormone, but also on sermorelin. So sermorelin was studied in children with short stature and shown to improve growth. So that's where, you know, we get some of these peptide secretagogue data, right? So obviously, I think it's important to do a proper assessment, make sure that the child is still in a growth phase, in bone-wise, that they're still able to grow. And if so, it can definitely be considered to give these peptides to children, yes. Yeah, and I agree. You're welcome, and I agree with Ursula's comment. We know that the HRT does not cause cancer, and it is unfortunate. I agree with you. But still, there's so much, misinformation in terms of cancer and VHRT. It's very frustrating. And we have a lot of data, robust data that shows it does not increase cancer risk. So that, it's slowly but surely we'll get that.
Cool. Well, thank you very much all for joining, and thank you,
Yeah.
Dr. Martinez, for coming on the webinar and sharing some of the knowledge and expertise with us. I
Sure.
think
Thank
this
you
was a
all.
really nice session. So I think we'll kind of close it for today, and we'll open the shop, I don't know, next time with a new webinar topic, and I hope you'll join.
Wonderful. Goodbye. Thank you.
Yeah, bye.
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 Thanks. Bye.